Good afternoon, everyone, and welcome to another webinar that CR Kennedy are putting on for you. It's going to be about the DJI Phantom 4 RTK drone, how the mining industry can use it, as well as Pix4Dmatic and Pix4D Survey. So my name is Timothy Hammond. I'm the National RPAS Sales Manager at CR Kennedy, or Remotely Piloted Aircraft Systems, and definitely enjoy speaking about the mines, talking about them, hopefully educating you on the mines. As first job out of university, I wanted to make as much money as possible, so I moved to Western Australia and worked as a gold exploration driller. As you can see in those photos, super dirty, super dusty, long hours, but good money. After that, I moved up to northern Canada, where I worked on the open pit oil sands sites and then did some natural gas drilling for a couple of months after that, only to come back to Australia and trade the commodity up in Sydney for a couple of years. So the DJI Phantom 4 RTK, just a quick recap of what it can do. It's got a 30-minute flight time with a 7-kilometer transmission distance, as well as its what it's known for. It's centimeter level positioning, 1-inch CMOS sensor with mechanical shutter, which is perfect for surveying, and a 20 megapixel camera. So people often ask, why would I pay 3-4 times as much for a P4 RTK versus just the normal Phantom 4? And that would be because the built-in RTK module ensures strong magnetic interference doesn't affect the drone when it's in flight, and these mining sites that you'll potentially be using them on always have some sort of interference which can mess with the drone's compass and calibration. As well as that, you've got the time sync, which increases the processing efficiency. So when you're putting it into Pix4Dmatic and Survey, like we'll demonstrate later, basically instead of trying to solve the puzzle with random pieces all over the place, at least with the RTK module, it's going to know fairly well where the image was taken and at what time. The other benefit is that you need less GCPs, so you don't need to go out on site and put 20 or 30 down. You can get away with about 5 as a minimum. And the final thing is their mission planning software. You don't get any of this sort of functionality on the standard Phantom 4 Pro drone, unfortunately. This is just unique to the P4 RTK. So, why do mines need drones? Well, they increase safety to on-site personnel. They allow more accurate stockpile measurements. It's a reduction in traditional surveying costs, as well as operational planning benefits and compliance with regulations. So safety is obviously of very high importance on a mine site, and high walls definitely come under the category of potentially being unsafe. So, this is just due, I guess, because there's loose debris, you've got unstable surfaces, and cracks that you may not know existed until you're going out to inspect them. That's why if you do have the ability to use a drone, and what I'm showing you here is what we captured, a 3D model of a mine site, and basically you're getting such detailed images that you don't have to send a member of staff out onto the site to check for potential erosion or cracks that may have formed or loose rocks that could potentially fall on someone else. You can literally do it in a 3D model before something occurs. The next thing is blast zones. They're not necessarily the safest area for a person to be. So if you can do most of the work that a person on the ground would do via drone, obviously it's going to be a lot safer for everyone. A third safety precaution that drones can help out with is stockpiles. They don't sound like much, but they can get fairly high. So even if someone's going out to traditionally survey the stockpile, there's always the hazard that they could trip or fall whilst climbing up or down the stockpile, as well as potentially getting hit by a piece of machinery whilst out on site. That moves us on to the fourth safety concern is machinery. If you need to inspect roads, walls, dams, safety barriers, etc., machinery is always going to play a big role in potential incidents on site. So using a drone could potentially remove these hazards and exposure sites for personnel, because they're constantly moving. There's dusty environments, so low visibility, and just something to stay out of their way from. So one of the greater benefits, I guess, that most people would have heard about is accurate stockpile measurement. And so since stockpiles they're not regular by shape and they have craters, it's difficult to estimate their volume with great precision using traditional methods of surveying such as GNSS surveying. Whereas with drone data, they capture thousands and thousands of data points for each stockpile, which makes them far more accurate and far timelier than the old methods, which potentially took hours, whereas now you can fly over a stockpile and it only takes a number of minutes. The benefits of this also include the ability to have a more accurate forecast model for what the actual mine site is going to be able to produce, as well as a sneaky one is when subcontractors say that they've removed X amount of dirt, when realistically the drone data says that they've only removed this amount of dirt. So it's a good way to call people out on if you feel like someone's doing a dodgy on you. Operational planning, a huge aspect in mining. Aerial images of the site enable regular visual assessment of the state of haul roads. So this provides valuable data such as length, slope, and turning angles. And with this information, you can alter or adjust the roads for your haul fleet, and hopefully cut fuel costs, which is also major expense in the industry. In general, though, drone data helps ensure that the roads are built to design and that they meet the current legal standards also. So, frequently obtained UAV aerial images, they help planners regularly monitor the mine features such as slopes or tailing dams, and they also ensure that the regular maintenance of dams are completed in a safe and timely manner and allow for the identification of crevices, erosion, wall damage, and basically anything else that could go wrong. They can identify it before it does go wrong. And this can prevent disruption to the site if unwanted water, i.e. rain or sediment flow, are really planned for ahead of time. Blasting is another aspect that benefits from the use of a drone survey, and these models help to accurately analyze the area to be drilled and calculate the volume to be extracted post-blasting. So this data, it allows you to better manage resources such as the number of trucks that you may need on site, and a comparison against surveys taken before and after the blast will allow volumes to be calculated more accurately. And this is going to be improved for future blasts. It's going to cut the costs of explosives if you know where to drill. And as well, it's going to cut the time on site and drilling costs. So now that we've seen the benefits of using drone data in the mines, it's time to talk about Pix4Dmatic, which is the post-processing software, which really gives you the deliverables from the data capture to being actually able to use the data in a way that's going to help the mine site. So in order to get actionable data, you've got to acquire the input data. So that's going to be going out and using your drone, whether that's the DJI P4 RTK, whether it's the Wintra 1, the DJI Matrice 300 with a P1, that's going to be up to you, as well as what software you're going to be wanting to use. I mean, the DJI inbuilt software is superb for pretty much doing all data captures, but if there's some particular scenario that doesn't work, doesn't suit your needs or doesn't work out, then yeah, there's Drone Deploy, there's Pix4D Capture, there's a number of software out there. So it's really what's going to benefit you or your company. So after you've gone out there and captured the data, whether it's a 2D or 3D model, 3D obviously better to perform volumetric calculations. 2D maybe just giving you an oversight of the mine area to create a progress report for your investors. That's whatever you need. So last week on the 21st of September, Pix4Dmatic released their stable version of 1.19. So what's new? First up, it's first easy LiDAR and photogrammetry workflow on desktop with Pix4D catch data compatibility. This is dense and depth point cloud processing and fusion. You've got the support of oblique imagery, in addition of new processing options and an actual template for oblique projects. You have a sky filter option in the densify step, so this will automatically remove the sky from the dense point cloud. As well as you've got 3D textured mesh, so you can create the generation of that and export that. And a great feature is the auto mark button in the image viewer. So this is for top-down or nadir images only, but it will pretty much after you've marked a couple of GCPs, tap this button and the software will automatically determine where the other GCPs are and mark them in for you. So time saver. And you've got proxy server support. Camera support, also an amazing feature of Pix4Dmatic. It's compatible with any RGB camera with basic XF or XMP tags, and there's no sensor size restrictions. Alright, so onto the juicy stuff, the essential outputs. Pix4Dmatic can output an ortho mosaic, so whether you need it for town planning, top down, really well stitched together of large scale images. That's one of the outputs. DSM, so if you're a mine site and you need to know where the water's flowing or the lowest point in the pit, that's also capable. Point cloud, if you need to measure some points or do accurate measuring from a 3D model, that's available, as well as a textured mesh, which is great for doing presentations and gives you a really accurate model of what the actual target surface looked like when you're modeling it. And of course, you've got the ease and ability to export it into Pix4D Survey. So that really saves exporting it into another third-party program and then re-importing it into your own CAD design software. So this is just one of the mine sites data samples that we had. And as you can see, this is the DSM to show the highest and lowest points of the mine site, as well as your textured mesh, I do believe, and point cloud. And that was a quick flash up of when it automatically detected the GCPs, which is pretty nice. So yeah, 2D, 3D. Oh, you can't even see the whole screen on the left, sorry. But yeah, so that's obviously the haul roads, and you can easily create the angle of the slope, how rocky, how well they're paved, straight from Pix4Dmatic. So the real benefit of Pix4Dmatic is that it's designed, not purely, but it's designed for large data sets. So this one, for example, in, I'm not even going to pronounce it, Echelons, Switzerland. Sorry, I don't know if that's correct, but we'll just go with that. So 6 square kilometers was captured in 10,600 images, and it only took 46 hours and 42 minutes to process, with a GSD of 2.27 centimeters. So like normal processing, I'd like probably maybe 4 to 5 days with the same sort of spec computer, but with Pix4Dmatic's new algorithm, yeah, it's significantly faster. All right, so a lot of the questions, I'm not sure whether you guys came to the previous webinar that I hosted, but it was on Pix4Dmatic, and a lot of people didn't know what the difference was between Pix4Dmatic and Pix4D So, Pix4Dmatic is optimized for corridors and large data sets of more than 5,000 images. It's on average 50% faster. It's more reliable for large projects. It's easier to learn and to get started, so low switching costs. Like the layout is, you're not overwhelmed with a lot of buttons or features. It's all kind of hidden, but all the power, the processing power is still there if you do want to get more advanced features. So Pix4Dmatic, you can apply a geoid elevation and vertical coordinate system to the RTK data. And unlike Pix4D Mapper, if you've used it, you can only do the ellipsoid offset. And the next thing is that it has native integration with Pix4D Survey, so you don't need to export it into a third-party software and then import it into a CAD design. You just go straight into Pix4D Survey. And it's the only desktop software that fully supports the terrestrial Pix4D catch workflow with the LiDAR and RGB image processing. Whereas Pix4D Mapper, in a nutshell, is the Swiss knife for photogrammetry, which means it'll take video, multispectral, thermal, fisheye, spherical, basically any kind of camera. And to put it bluntly, all these three are part of the geospatial suite. So if you need any more information about that, please visit pix4d.com/matic, and their support page is second to none. Honestly, any question that you can think of, it's already been answered. It's already been made into a video, and their community on Pix4D's website often has a lot of questions that hopefully you'll be able to find whatever problem you're having a resolution. So next up, Pix4D Survey. Bridge the gap between photogrammetry and CAD. So it's going to be the same workflow as Pix4Dmatic described. You've got to acquire the data, you've got to process it, and then the next step, which typically takes the longest of all three, or four, is that you've got to export it into a third-party processing software and then re-import it into a CAD program. So we all know that there's tons of software out there which provides a partial solution for this, but there's nothing that provides an end-to-end solution, and that's where Pix4D Survey is hopefully going to come in and bridge this gap. So why does this gap exist? Well, there's big sets of images like UAV, LiDAR, photogrammetry technology. They're all evolving way faster than what CAD's software can follow. And final design still requires CAD drawings. Orthomosaics, that is, they're too big to draw on in like Civil 3D. CAD software can't handle nice point clouds. Final designs still require CAD drawings, and many cumbersome software, tough learning curve, and they all require a different ecosystem. So Pix4D Survey, though, you extract the data you need. It's the next step in the Pix4D photogrammetry workflow to simplify your connection to GIS and CAD, and it makes planning and designing easier. And not to mention, it allows for point cloud, terrestrial, and aerial data combined. And the workflow, it's so much more easier. It's such an optimized workflow. Like, you capture the images with a drone or any laser scanner, transfer your images into the digital point cloud, and then boom, straight into Pix4D Survey. Extract only the data you want from your project, only the elements, and then open the simplified, accurate data in a CAD or GIS software with layers and the original properties. In addition to this, there's also the built-in vectorization tool, and the algorithms are only getting smarter and smarter with Pix4D Survey. So selecting, for example, in this case, the lines, the walking lines, it pretty much is able to do it itself. So the next cool thing is the terrain workflow focus. And so you'll be able to filter point cloud to terrain and not terrain. You can vectorize break lines, create a smart grid of terrain points, and make a tin from the grid and break lines. So I'll show you that in just a sec. So here we're going to classify the point cloud as terrain or not terrain by selecting your sample distance, flat being for like open areas, irregular being for areas with more detail in the terrain. We'll just quickly filter terrain. So there we go, straight up. Now we're going to create a grid of points. So for this, we're choosing 2.5 meter as sample distance. And what that's going to give you is it's generated off the selected sampling distance between the points. So this creates spot elevation and allows for simplification of the number of point clouds. So there are two types. Just if I touch on that for a sec, there's regular versus smart. The regular grid, it's generated based on the selected sampling distance between the points, whereas the smart grid creates points only where the changes in terrain elevation occur. So this is gonna, like the smart option, it's gonna only give you points where the change in elevation in terrain occur, despite using the same sample distance. So there's going to be a lot fewer points that are generated while accurately describing the terrain. And this makes for a smaller output file, and it's a lot easier to import into any CAD software. So now, yeah, we've created the tin file, and as you can see, super simple to I guess here, draw a point on the actual haul road, see how long it is, see the slope, and see the actual location that it was taken in. Now we can remove it, add it back in. And you will notice that the grid, well, in this case, the regular grid, it's pretty much identical. Well, it should be fairly identical to what the actual terrain layer was identified as. All right. So, as well as with Pix4Dmatic, Pix4D Survey also released their most up-to-date version last Monday or Tuesday, the 21st of September. And what this allowed for was an improved export dialog, so more flexible and complete options. The coordinate system conversion on import, so you can actually adjust the RTK data when importing it in. I'll show you that in a sec. Volume calculation, super good. It's wherever you want to click. This is what I found working with this over the past week, was that wherever you click, it's actually going to click onto that point, as opposed to in other software you may think that you're clicking on a point, do the calculation, and at a later stage realize that that calculation was wrong. If you're pointing at the ground, Pix4D Survey knows that you're pointing at the ground. It's not going to click you up like 2, 3, 4 meters up in the air and just give you some stupid number that doesn't make any sense. All right, so this is the quick workflow. This is what I'm talking about. 1, 2, 3, 4. It's noticing that it's on the ground. It's giving you the base layer, and then from there, you click it. You right click to deselect, selecting anything else. And then what I've done here is reduce the point size so it's easier for me to see the actual stockpile or area that I'm calculating. And then you can zoom in and ensure that the area that you've selected is the actual area that you want. So there you go, nice little overlay of what you're actually seeing versus what the 3D computed stockpile looks like. So now you're asking, what's the difference between Pix4D Survey and Pix4D Mapper? Well, Pix4D Survey is optimized for fast extraction of the details you need from large geospatial projects. It supports faster vectorizing. It's more reliable for large projects. It's easier to learn and to get started. You know, it's not filled with all these buttons and tabs and icons that are confronting to you. It's simple, it's laid out. It's a really, really nice user interface, as well as its low switching costs, which until December actually, Pix4D has some great offers. I think about 50% off for Pix4D Survey to get people involved and get people on board. So if you are interested, please feel free to reach out to me, thammond@crkennedy.com.au, otherwise sales@crkennedy.com.au, and we'll help you out. Pix4D Survey, as well as Pix4Dmatic, can apply a geoid elevation and vertical coordinate system to the RTK data. So even if you set them up as an arbitrary in Pix4D Mapper, you can still change that and apply your coordinate system in Survey. As well as that, it's got its native integration with Pix4Dmatic. So whether you're exporting out of Pix4Dmatic and into Survey, there's literally just an option on the top left-hand side of the screen where you go to save the project, which will say open with Pix4D Survey or Matic. Pix4D Survey, it doesn't do photogrammetry, but it depends on the 3D input. So whether it's from Pix4Dmatic, Mapper, or Pix4D Cloud, if you want Ray Cloud. Also point clouds alone work. So if you're exporting out of a LiDAR sensor into a .las file, that will work in Pix4D Survey. And just to reiterate once again, Pix4D Mapper is the Swiss knife for photogrammetry. So that means it will take video, it will take multispectral, thermal, fisheye, spherical, basically any type of camera That's what Pix4D map is famous for. So these are the 3 things that are part of the geospatial suite, and hopefully Pix4D Survey is going to bridge the gap for your next project. And if you do need any other information, please don't hesitate to visit pix4d.com/survey. Now, one last little thing before I go and call it a day. Pix4D is holding a virtual user conference. So virtual, you don't have to fly anywhere. Sit at home on your laptop, and you can register for free using the code Pix4DUC21, or if you've got your own Pix4D account already, you can register there and watch for some keynote speakers to guide you on Pix4D's geospatial suite. Pretty much anything that you need to know, they're going to know, and if if their question's not answered there's always the Pix4D community, which has the Q&A sections updated all the time. So guys, that is it. It has been a pleasure speaking to you about the DJI Phantom 4 RTK, how it benefits the mining industry, Pix4Dmatic Pix4D Survey. And as you've watched this, Pix4D have actually given us some trial codes available, so if you do want them, please feel free to email me and I can get you a month-long trial for Matic or Survey. In addition to this, we do have some great deals in October at CR Kennedy for the Phantom 4 RTK, so if you've been hesitating due to the cost, shoot us an email, and yeah, we've got some nice little bundles packaged together. So my name was Timothy Hammond. Any inquiries, any questions, anything else that you want to know about any of the topics that we've covered today, feel free to email me at thammond@crkennedy.com.au or sales@crk, and yeah, someone will be back to you shortly. Anyway guys, if you do have any questions right now, feel free to leave them in the chat, and like the last webinar that I hosted, I will find out the answers and email them all to everyone once I've found them. Thanks guys, have a good day, bye.